With the case for the most part finished, it's time to get some of the components mounted. The fans and heatsink are where I'm going to start. The fans are the ones that came with the Noctua heatsink. They seem to be a pretty good quality 120mm fan. So the mounting holes are 105mm square pattern. So it's just a matter of measuring where to put the holes and then drilling them. At each mounting hole on the fan, there is a narrow slot. Seems like a good place to hold a nut. The only problem I ran into here was that the 3mm nuts I have will just spin in the slot, and the 440 nuts I have are too wide to fit in the slot. So what I did was grind down two opposite sides of the 440 nuts so they would fit. I overdid the grinding a bit on a few of the nuts, but they're still plenty strong for this. Now the bottom nuts are a little tricky to install, but not too bad. Of course, if the fans have to be replaced, the whole thing will have to come apart. Originally, I was going to leave the fans attached to the heat sinks, but the spring clips that held the fans in place created a small gap on the air intake side, and I was worried that too much of the hot air might get sucked back into the fans. So either I had to make some kind of seal for the fans to push against, or mount the fans right on the case, and I think I chose the easier path. I'm going to make a bracket that a heatsink and Mosfet driver board will mount to. The bracket will be made from 3 pieces of aluminum bar. The base is a 1/4 inch thick, 1.25 inches wide, and 3.7 inches long. The risers are 3/8 inch thick, 5/8 inches wide, and 5 1/4 inches long. The risers will be attached to the base with screws. So to make sure I get my holes drilled correctly, I'm going to glue the risers to the base with some CA glue. Making a jig out of 1-2-3 blocks works pretty good. I found that by putting a little bit of lubricant on the 1-2-3 blocks where the glue might squeeze out, keeps anything from really sticking. I will hold this in place for a little over a minute. Then gently remove the bracket and reset the jig for the other riser. After gluing the second riser, I will let this set overnight before doing anything else to it. I know the location for most of the holes in the bracket, so I'm going to mark for them now. When the blue dye is well dried, it really makes for some fine scribe lines. I'm usually rushing it, and I shouldn't. The 2.5mm holes get drilled through the base, which has the location marked on it, into the riser almost the full length of the drill bit. I don't want the tap bottoming out. I'm going to mark which riser goes where. With my marking by hand and drilling by eyesight, there will be a bit of difference between the two. Just a little tap will separate the risers from the base. Going to finish up drilling the base. The clearance holes for the number 832 screws that will hold the bracket to the case are drilled with a number 15 drill bit. A little on the large size for an 832 screw, but I want to have a bit of wiggle room in positioning the heatsink. 3.4mm clearance holes are drilled for the base to riser holes. 3.4 exactly because the pilot on my 3mm counterbore bit is 3.4mm. I'll position the stop on the drill press to drill about 1/8 inch into the base. This way the heads of the screws will be recessed. allowing the bracket to mount flush on the bottom of the case. And the base piece is finished. All the holes to be threaded on the bracket are in the risers. I'm taking a bit of extra care in making sure the 3mm tap enters the hole straight. With such a small tap, it's very important. And it's a slow process. I sure don't want to break the tap. But there are only 8 of these holes to be threaded, so it won't be too bad. 2 more threaded holes to make. These will be for number 832 screws. The holes get drilled with a number 29 drill bit. Don't have to be near as gentle with this tap. I have broken one before, so don't want to go wild with it, but if it's aligned straight, it will cut right through the aluminum. A little deburring, and they are ready to go. Now let's see how well they fit. Get the right pieces in the right place. Tighten the screws down. Feels good and solid. I think this is going to work just fine. A bit of modification has to be done to the heatsink. The screw sockets and springs have to be removed from the mounting arms. There is just a small C-clip holding each of them on. I've already decided that I'm not going to use any electrical isolation between the drain tab of the Mosfet and the heatsink. Just cannot afford the increase in thermal resistance. But I don't want the bracket to be electrically connected to the heatsink. Here, I'm going to cut up some 2-3 mica insulators. They will go in between the aluminum bracket and the heatsink. Now I made some nylon bushings to keep the screws from touching the heatsink. The bushings and screws are a pretty tight fit. I hope I measured right for my hole spacing. That seems to be a pretty good fit. Cut that extra mica off there before I get cut on it. Now, to do it all again, and then we will be ready to go. Using the heatsink assemblies to mark where the holes should go. I noticed that each heatsink has a slightly different lean to it, so they are not going to be interchangeable. I'll drill and tap these holes for 832 screws. I'll just push the heatsink up against the rubber bumpers on the fan and then tighten down the mounting screws. Two things I've still got to do with the brackets. Mosfet mounting, that's still a work in progress. I would like to be able to remove the MOSFETs without removing the heatsink. And the Mosfet driver board mounting. But that looks good. Before I install anything else, I wanted to do a little fan test. These do seem like pretty efficient fans, less than 180 milliamps at 12 volts, in what is almost free-flowing air. Blocking air to one of the fans increases current by maybe 6 to 7 milliamps. Of course, that's on the intake side, so I don't really think I can compare that to output blockage, but I guess I am. So right at 180 milliamps with the case put together. Feels like good airflow. I would have liked there to have been no increase in fan current, but it really is less than a 5% increase, so I don't think I'm seeing a huge resistance to airflow. I think that will work. Guess I won't know for sure till I get it fired up and measure the MOSFET and heatsink temperatures. The display input PC board needs to be spaced 0.6 inches from the case front, and I don't have any spacers that length, so I'm going to make some out of some 1/4 inch aluminum rod. I'll cut myself 4 pieces of rod that are a little bit on the long side. Then make sure I have a nice flat face to work with. Next, make sure my starting hole is in the center. Then drill out the length of the rod with a number 43 drill bit. Chamfer the hole just a tiny bit to get it ready to tap. This is a 440 bottoming tap, and I have the tape on the tap to mark the just over 0.3 inch mark. So one end of the spacer gets tapped about halfway. Unfortunately, the threads on the tap are not long enough to go through the entire spacer. Then I turn it around in the chuck, get a good flat face on it, then measure the length, see how much I have to take off. Trim it down to the right length, then tap this end of the spacer. I will chamfer the ends just a bit. It makes them feel nice. Clean it off, and then double check the length. That is way good enough. Now rinse and repeat 3 more times. The spacers get attached to the front of the case. The buttons go in, and then the PC board gets mounted. I was planning on using some small springs between the buttons and the switches. May not need them. The buttons may rattle a bit without them, but that will be a final assembly kind of decision. I'm happy with that. The bus bars are some 1/4 inch thick by 3/4 inch wide copper bar I had left over from the CD welder I'm building. It is a little oversized for this, but I have it on hand. I'll just have to work around the holes that I have drilled in it. I'm going to use 3 pieces, and the only holes I'm drilling now will be the mounting holes. To mount the bars in the case, I'm going to make some acetal spacers. They are a little over 0.76 inches long and a ½ inch in diameter. I will thread them for number 832 screws, and for these the taps are long enough to thread all the way through the spacer, which is nice. The clearance holes in the case are a little oversized. I want the bars to be parallel so the front of the case can slide off. This will be the positive load terminal. I'm putting this in temporarily for alignment purposes. The third bar will mount above this one, and they have to be electrically isolated, so the holes in this copper bar will get enlarged for a bushing to fit into. The very short bar is the negative load terminal. This one is going to be a bit tricky to connect to. Now to mount the third bar, I need to make some isolation spacers. They have a clearance hole for an 832 screw. The bar is a 1/4 inch thick, so I'm going to have the bushing fit into it about 0.235 inches. The clearance holes in the bar are 0.3 inches in diameter, and I don't need for the spacer to be a perfect fit or anything, just need to isolate the 2 pieces of copper. I'll cut the spacer a bit long and then trim it to length. They will space the top bar a 1/4 inch above the positive terminal bar. So the positive terminal bar goes in, the isolation bushings go in it, then the top bar fits on, and the whole thing gets screwed in place. No connection. That's very good. Now all I have to do is figure out how to connect my current shunt to the bars. Thank you for watching.